Now, you'll never be asked to prove this one because it's on your formula sheet. Anything that's on your formula sheet, you can automatically use. So you'll never be asked to prove this one, but in order for it to get onto your formula sheet, someone had to prove it at one time. So the question is, how do you prove this? And like I said, if we go through all the strategies we've learned so far, none of them work, and we're completely stuck. And then I would tell my class, you know what? I'll give you a hint. You have to use something you learned in kindergarten in order to prove this. And you're like, what? And some of you might have already learned it before you even got to kindergarten. So the strategy for this proof is using something so basic that you learned it in kindergarten. And one of the very first things that you learned in math was 1 plus 1 is 2. I know it's amazing. It's crazy. You'd be amazed how many grade 12 students make mistakes with ones. Because it's so easy, I get 1 times 1 equals 2 all the time on tests. Right? You laugh at it, but can you see you're just not, it's like, it's so easy, you're not thinking, you're thinking about the next step, and your brain is like, oh, 2 ones. And you're like, oh, 2. So, happens more, and you're like, but what I can do with this 2 there is I can say, well, 2 thetas is the same as a theta plus a theta. And that seems so basic that sometimes we don't even think in a proof that we should try something basic, because like that's too easy. However, now I can say, hey, this can be my alpha plus beta formula that we learned yesterday. And if it's my alpha plus beta formula, then I'm going to have sine alpha cos beta plus cos alpha sine beta. And then these are like terms, and we get to use that kindergarten skill again. One of these plus one of these will make 2 of them. And our proof is done. It's that simple. So similarly, we could do the same thing with cos on the top of the next page. And of course, on your formula sheet, they have these identities, and they're called the double angle identities. Now, interesting, I'm going to put a box around them in green. Do you notice that there are 3 for cos 2 theta? So if you have a cos 2 theta, you have a choice of any one of those 3. And right above the page, they explain, or I guess it's on, for you, it's just back on page 653. If this is the one you would get if you used your formula sheet, or like if you use the alpha plus beta formula, you would get cos squared theta minus sine squared theta. But since we know that sine squared theta is equal to 1 minus cos squared theta, we could do that substitution, and then we would get a formula with just cos. Same thing, if we change the cos squared to 1 minus sine squared, then we would get a formula with just sine squared. And for my AP calculus class right now, they're using these quite a bit in some of their calculus work. So these would be ones I would say, of the formulas, the double angle ones, you can memorize those completely. That's going to be more helpful for your AP calculus class than the alpha plus beta ones. And I do really feel like if you can memorize just this one, it's really easy to get to this one and this one with a simple substitution that sine squared is 1 minus cos squared, or cos squared is 1 minus sine squared. So we have our double angle identities, and just like our alpha plus beta ones, and all of our identities, if you ever see the right-hand side of one of these identities, that means you're allowed to, without showing any work, change it to the left-hand side, and vice versa. So if I see a sine 2 theta in a question, I can immediately change it to 2 sine theta cos theta, and see if that makes my question easier. So what are some questions that we'll get? We will get triangle questions with double angle identities. Given theta is in standard position with its terminal arm in quadrant 4, and cos theta is 2/5, up to that comma, we have had so many questions start that way, right? And then they ask us to find something else. But the start of that question is like, hey, this is a triangle question. I can draw this angle. It's in quadrant 4. What does that mean? Well, it means it's here. Then I can make a right angled triangle and label my reference angle. And if cos is 2/5, that means the adjacent side is 2, the hypotenuse is 5. And in a triangle question, an a squared plus b squared equals c squared, it is not hard to find out that this length is the square root of 21. So our triangle questions always sort of have that information as a startup. They tell you the angles in standard position, some sort of information to find out what quadrant it's in. This one was really easy because it was pretty obvious it was in quadrant 4. But sometimes they'll give you hints that, oh, like I can see as a little bit more difficult, I wouldn't tell you quadrant 4. Instead, I would tell you that sine of theta is less than 0. Because then you would have to use your cast rule and say, oh, cos is positive, sine is negative, that has to be in quadrant 4. Okay? But there will always be enough information for you to figure out what quadrant it's in, so you can draw your triangle, do a squared plus b squared equals c squared. And then triangle questions always ask you to find something. So in A, they ask us to find sine 2 theta. Now sine of theta is negative root 21/5. Can I just double it? No. This is a function. The only thing we can do with the sine 2 theta is use our new formula and say it's equal to 2 sine of theta cos of theta. And then from our triangle, we don't know what theta is, but we know that sine of theta is negative root 21/5, right? Because from this triangle, we were given that cos of theta was 2/5, but now that I've drawn the triangle, I can say that sine of theta, and it's in quadrant 4, so it has to be negative. I could also do tan of theta. Right? The triangle lets me figure out all my trig functions, but they're all for theta. They're not for 2 theta. And you're going to find that when you do have double angle identities, you almost always want to take the left-hand side and switch it to the right-hand side so that you get back to regular angles without the double angle inside. Now we have to write our answer as a single fraction, so we're going to have to multiply this out. This is 2/1. How do we multiply fractions? We multiply our numerators, and we multiply our denominators. Part B, we have cos 2 theta, and we have 3 formulas to choose from. I will tell you, all 3 formulas will give you the right answer. Usually, there is one that is slightly better. In this situation, They're almost identical. If I would say one is slightly better, I would say it is this one. It's the only one that doesn't use sine. And why is not using sine slightly better? Do you see in the question? They told us what cos is, right? It's pretty hard to get cos wrong. It happens. There are students that read cos theta equals 2/5 and then they write 2/3. It still happens that if I give you something, you can still get it wrong. But we had to figure out sine of theta, right? We had to do a squared plus b squared equals c squared. There was a chance that we did a mental math error here. So using cos means that as long as we can copy things down, we're not going to be making any mistake on mental math errors. So now to figure this out, what do we do with the squared? I have 2. Now cos was 2/5. So cos squared will just be 2/5 squared. Minus 1. Do our order of operations, so square first. How do I multiply fractions? I multiply the tops, multiply the bottoms. That'll give me 8/25. How do I subtract fractions? I'll need a common denominator. So I'm going to change that 1 to 25/25. And I get negative 17/25. Now I want you to look at the answers in A and B. That's a hint. I'm going to add C. Theta was in quadrant 4. In what quadrant is 2 theta? If you take an angle in quadrant 4 and you double it, where will it end up? That's kind of hard to visualize, isn't it, a little bit? Okay? But if we can use the answers from A and B to figure it out, what quadrant do you think it's going to be? It's in quadrant 3. How can I use the answers in A and B to figure that out? They're both negative. So our CAST rule would say if sine of 2 theta is negative and cos of 2 theta is negative, then it has to be in quadrant 3. All right, questions for this one? Circle just number 9.